For 30 years, the consensus answer to which manufacturer built the best driver supercar has been one word: Porsche. The 911 has been the benchmark since 1963, the car the magazines compared every new sports car against, the car the racing community has run in every category since competitive amateur racing existed, the car every other supercar in the world has been measured against, and that, for 60 years, has mostly won the measurement. Then, in 1990, a Japanese company that had never built a supercar before walked into the segment with a car engineered from scratch for one purpose. The purpose was not to compete with Porsche. The purpose was to beat it. The Acura NSX arrived in the same showroom era as the Porsche 911 of the same year, the 964 Carrera. The Porsche carried 60 years of motorsport heritage. The NSX carried Ayrton Senna's chassis notes, Honda's Formula One technology, and an aluminum body the industry had said was impossible to mass produce. Did Porsche actually build the better supercar in 1990? Or has the 911 community been protecting the legend at the expense of what the cars actually did when they were tested against each other? To understand what happened when the engineering revolution met the engineering tradition, you have to go back to Tochigi Prefecture, Japan, in the spring of 1985. In 1985, a 37-year-old engineer named Shigeru Uehara was Honda's specialist in vehicle stability and handling performance at Honda R&D in Tochigi Prefecture. Uehara had joined Honda in 1971. He had spent 14 years working his way up through the company's engineering ranks. He had not, in any of those 14 years, been told that Honda would build a supercar. Honda was a maker of economy cars and motorcycles. Honda had not, since the company's founding in 1948, built a vehicle in the same segment as Porsche or Ferrari. That changed in 1985, when Honda's board of directors appointed Uehara as large project leader of a midship research project, Honda's term for the development effort that would produce the company's first supercar. The project built directly on the HPX concept that Pininfarina had unveiled for Honda at the 1984 Turin Motor Show, the wedge-shaped mid-engine prototype that had signaled Honda's ambitions in the segment before any production program had been authorized. The brief Uehara received was specific. Honda needed a car that could bridge the gap between its mass-production front-wheel drive sedans and the Formula One cars the company had returned to building in 1983. The car had to be the new face of Honda. It had to demonstrate that a Japanese manufacturer could build a credible supercar from scratch. And it had to do so with no compromises. Honda had committed the engineering resources to make the project succeed without the budget constraints that define the company's volume products. The target Honda's engineers identified was specific: the Ferrari 328, and later the Ferrari 348 that would replace it. The 328 was the entry Ferrari of the mid-1980s, the car that established what a credible mid-engine supercar from the dominant Italian manufacturer was supposed to be. Uehara's team would build a car that beat it, not matched it. Beat it. The development program that emerged was extraordinary in its scope. Uehara organized the engineering effort around a core team of 200 Honda employees who would later hand-assemble the production cars at the dedicated Tochigi facility. The chassis development was conducted at Honda's Suzuka circuit, where the team spent an entire month in the early development stages running prototype evaluations. The chief designer was Masahito Nakano. The exterior styling was finalized by a young Honda designer named Ken Okuyama, the same Ken Okuyama who would later design the Ferrari Enzo for Pininfarina. The body design was studied for visibility against the cockpit of an F-16 fighter jet, with a cab-forward layout that placed the driver in front of the power plant for the kind of forward visibility that production supercars of the era did not provide. In February of 1989, 3 years into the development cycle, Honda asked Ayrton Senna to drive a prototype. Senna was already in Japan testing the new McLaren-Honda Formula One car at Suzuka and agreed to the evaluation between his testing sessions. He was at that moment the most accomplished Formula One driver in the world, racing for McLaren on Honda engines. Senna drove the NSX around Suzuka, returned to the pit lane, and delivered a verdict that became part of NSX engineering folklore. "I'm not sure I can really give you appropriate advice on a mass production car," he told the team, "but I feel it's a little fragile," a way of saying the chassis lacked the rigidity that a serious driver's car required. The Honda engineers responded by raising the chassis rigidity targets in April of 1989. Over the months that followed, the team would ultimately increase the chassis stiffness by approximately 50% over the prototype Senna had tested. They returned to Senna for further evaluation at the Nürburgring. The final production NSX chassis carries Senna's input as a direct lineage. A Formula One world champion contributed to the development of a production supercar in ways that no other production sports car of the era could claim. To understand what Honda actually built, and what made the NSX the car that reset the entire supercar segment, you have to start with the engineering decisions that produced the world's first all-aluminum production car. The NSX's engineering case rested on 3 pillars, and each one represented a decision that no production manufacturer had made before. The first was the body. The NSX was the first production car in automotive history to be built around an all-aluminum semi-monocoque body and chassis. Every Porsche, every Ferrari, every Lamborghini, every Mercedes-AMG of 1990 was constructed from steel. Aluminum was harder to weld than steel, and the fixtures and tooling required to assemble an aluminum body cost an order of magnitude more than the equivalent steel tooling. The cost penalty had been considered prohibitive for any production application beyond hand-built specials in run lengths of a few hundred. Honda built the tooling anyway. The construction of the dedicated Tochigi plant was completed in May of 1990. The body was constructed using extruded aluminum alloy frame members, joined by a combination of welding and adhesive bonding techniques that Honda had developed specifically for this application. The result was a body structure that weighed approximately 200 kilograms less than the equivalent steel construction would have weighed. A weight savings of nearly 440 pounds, applied entirely to the structural shell of the car. The dry weight of the production NSX was 3,020 pounds. The Ferrari 348 dry weight was 3,071 pounds. The Honda was the lighter car. The second pillar was the engine. The C30A was a 3-liter, 24-valve, double-overhead camshaft V6 with Honda's VTEC variable valve timing system, an 8,000 RPM redline, titanium connecting rods, and forged pistons. The engine produced 270 horsepower at 7,100 RPM and 210 pound-feet of torque. The figures were modest by the standards of the segment. The Ferrari 348 produced 296 horsepower. The Corvette ZR1 produced 375, and the contemporary Porsche 964 Carrera produced 247. The NSX was the second most powerful car in the segment, but it was also the lightest, and Honda's engineering had calibrated the engine for response and refinement rather than peak figures. The titanium connecting rods were the engine's defining engineering decision. Titanium is approximately 40% lighter than the steel that Honda would otherwise have used. The weight savings inside the engine, applied to the reciprocating components, allowed the engine to spin to its 8,000 RPM redline without the inertial mass of conventional rods to slow its response. No other production car of 1990 carried titanium rods in a series production application. The third pillar was the chassis. The NSX used a fully independent double wishbone suspension at all 4 corners, the same architecture every Formula One car of the era used, and the same architecture BMW, Porsche, and Ferrari were using on their production sports cars. What distinguished the NSX's chassis was the calibration. The suspension geometry had been validated through hundreds of hours of testing at Suzuka and at the Nürburgring. The damping rates had been refined through the input of Ayrton Senna. The result was a chassis that, by the consensus of every published comparison test of 1990, was the most balanced and the most communicative in the entire supercar segment. The American press response was decisive. In late 1990, Car and Driver conducted a comparison test of the new NSX against the Porsche 911 Carrera 4, the Lotus Esprit Turbo, the Corvette ZR1, and the Ferrari 348Ts. The Acura won. The magazine's editors described the NSX as the first Hera car with impeccable manners, a verdict that captured what every press outlet was discovering simultaneously. The NSX was as fast as the Ferrari. It handled as well as the Porsche. It cost less than either of them, and it could be driven every day without the maintenance headaches, the reliability anxieties, and the operating costs that European supercars demanded. The price was the final element of the engineering achievement. The NSX launched in 1990 at $60,600 in the American market. The Porsche 911 Carrera 4 cost approximately $70,000. The Ferrari 348 Ts cost approximately $140,000. The NSX was, in absolute dollar terms, between 43% and 57% cheaper than the cars it was being compared against, and it was winning the comparisons. The value proposition was unprecedented in the supercar segment, and it would not be matched by any subsequent manufacturer for the next 20 years. The NSX at age 35 has an ownership reality that is, by the standards of the supercar segment, almost unremarkable. Owner-documented examples of NSXs exceeding 300,000 miles on original engines, with no internal rebuilds and no catastrophic failures, are not the exception in the community. They are the documented baseline outcome for owners who follow the recommended maintenance schedule. In 2023, an Acura dealer in California documented a 1992 NSX that had accumulated 400,000 miles on the original engine, a figure that no Ferrari or Porsche of the era has approached. The single most consequential ownership consideration on the NSX is the timing belt. The C30A is an interference engine with a recommended timing belt replacement interval of 105,000 miles or 7 years, whichever comes first. A failed timing belt produces immediate catastrophic engine damage. The cost of the timing belt service at an Acura specialist, with the belt and water pump replaced together, runs between $2,500 and $3,500, depending on labor rates and the extent of related service performed at the same time. This is not optional maintenance. The buyer who skips the timing belt service is buying a future engine rebuild that will cost 5 times the maintenance avoided. The clutch is the second consideration. The NSX uses a single-mass flywheel and a conventional clutch, neither of which has any particular tendency to fail prematurely, but both of which are normal wear items that the owner who keeps the car for 15 years will eventually replace. The cost of a clutch service at an Acura specialist runs between $2,000 and $3,000, depending on the part specification. The work is routine. The community has documented the procedure. The parts are widely available. The pop-up headlight motors fail at predictable intervals. The replacement parts are inexpensive, and the repair is straightforward. The radio head unit on early production cars can develop pixel issues, with replacement units available through aftermarket suppliers. The air conditioning compressor will eventually fail and require replacement, a normal outcome for any 35-year-old car, regardless of make. The leather seats wear at predictable rates, with replacement upholstery available through specialist suppliers. That is essentially the complete list of NSX ownership considerations. There is no rust pattern that defines a generation. There is no head gasket weakness that requires periodic replacement. There is no electronic system that biodegrades with heat. There is no transmission with documented failure modes the community has had to develop protocols for. The car was engineered to be reliable, and the engineering achieved the intended outcome. Production of the first-generation NSX continued in various specifications through November of 2005. Approximately 18,000 examples were built across the entire 15-year production run, with about 9,000 sold in the United States through Acura dealers and the rest sold under the Honda badge in international markets. The car was hand-assembled by a team of approximately 200 Honda employees who built 25 examples per day at the Tochigi facility. The production volume was small by mass market standards. It was the largest production volume any all-aluminum production supercar had ever achieved. The NSX's cultural legacy has only grown since production ended. The engineering decisions that defined the NSX, the all-aluminum body, the daily drivability standard, the chassis tuned by a Formula One world champion, the emphasis on reliability as an engineering virtue rather than a secondary consideration, have influenced essentially every supercar built since. Ferrari moved toward aluminum construction. Porsche adopted the daily drivability standard. McLaren built its entire modern company around the same philosophy. The NSX did not just compete with the European supercars. It changed what European supercars were supposed to be. A clean first-generation NSX today sells for between $50,000 and $120,000 depending on year, mileage, and condition. The earlier NA1 examples with the 5-speed manual transmission command the highest values, with low-mileage examples in original specification approaching $150,000. The NSXR variants, the lightweight Japanese market specifications produced in very small numbers, command values into the high six figures. The car that sold for $60,600 in 1990 is now worth more than its original sticker price, an outcome that few new cars of any era have produced. That is the Honda answer. The car that proved an aluminum production supercar could be built. The car the Ferrari 348 was supposed to beat, and that beat the Ferrari instead. And the car whose ownership reality has been defined by routine maintenance items that any owner can budget for, and parts ecosystem support that no other supercar of the era has matched. But while Honda was demonstrating that engineering excellence could be applied to the supercar segment at scale, Porsche was preparing the next iteration of the car the company had been refining for 25 years. The 911 that Porsche launched in 1989 was not a revolution. It was an evolution, an 85% new car that looked recognizably like the 911 it replaced, that carried the same air-cooled engine architecture, the same rear engine layout, the same fundamental design that Ferdinand Alexander Porsche had penned in the early 1960s. To understand the 911 that Porsche launched against the NSX, what the German manufacturer built when the Japanese engineering shock arrived in the same showroom, you have to go back to the late 1980s, when Porsche was confronting the same question that every established manufacturer eventually faces: how to evolve a legendary car without losing what made it legendary. In late summer of 1988, Porsche began production of the 964 generation 911 at the Zuffenhausen factory in Stuttgart. The car was the third generation of the 911, the model line Porsche had been building since 1963, when Ferdinand Alexander Porsche had penned the original design as a replacement for the 356. By 1988, the basic architecture, rear-mounted air-cooled flat-six, rear-wheel drive, 2+2 coupe body, had been continuously refined across 25 years of engineering iteration, motorsport development, and customer feedback. The 911 was the most recognized sports car silhouette in the world. It was also, by 1988, in commercial trouble. The previous 911 generation, the G Series, in production since 1974, had been built across 15 model years with progressively diminishing engineering refinement and progressively obvious aging against the more modern competitors that had emerged across the 1980s. The Ferrari 308 had introduced the modern mid-engine Italian supercar formula. The Honda NSX was in development with engineering targets that Porsche's intelligence had identified. The American market was demanding more refinement, more reliability, and more daily drivability than the G-Series 911 could deliver. Porsche needed a new 911 that would address all of these expectations without sacrificing what the existing 911 community valued about the car. The car that Porsche unveiled at the Paris Motor Show on September 28th of 1988 looked, in marketing terms, like the same 911 the company had been building for 25 years. The proportions had been preserved. The greenhouse silhouette, the round headlights, the characteristic body lines, all of these were carried over from the G Series with refinements designed to integrate the bumpers more cleanly into the body. What the buyer would not see is that the 964 was 85% new compared to the G Series it replaced. The chassis was new, the engine was new, the transmission was new, the bodywork was new under the visual skin, the suspension geometry was new, the brakes were new, the electrical system was new. Porsche had executed the most extensive redesign of the 911 since the model's introduction, in a way that the casual observer could not see. The 964 launched with two model variants, the Carrera 4 with all-wheel drive, which became available first in late 1988 as a coupe with manual transmission only, and the rear-wheel drive Carrera 2 that joined the range the following year. Both used the same engine. The Carrera 4 was the first 911 to offer all-wheel drive, a meaningful engineering achievement for a car that had been rear-wheel drive for 25 years. The Carrera 2 was the traditionalist's car, the rear-wheel drive 911 in modernized form. Designer Benjamin Dimson had penned the exterior refinements in 1985 and 1986. Production began in late 1988 as a 1989 model year vehicle. The pricing, approximately $70,000 for the Carrera 4 in the American market, placed the 964 at the entry level of the European exotic segment, well above the NSX, but below the Ferrari 348. By the time the NSX arrived in American showrooms in 1990, the 964 was the established competitor that buyers were considering as the alternative. To understand what Porsche built, what made the 964 a credible 911, while also producing the engineering problems that have defined the generation's ownership reality, you have to start with the engine, the chassis, and the manufacturing decisions that Porsche made during the development cycle. The 964's engineering case rested on the continuity of the 911 tradition, while updating every component for the demands of the modern luxury sports car market. The M64 engine was new. The previous 911's 3.2-liter air-cooled flat 6 was replaced by a 3.6-liter air-cooled flat 6 with twin-spark ignition, the dual ignition system that Porsche had borrowed from its aircraft engine division, the PFM 3200 Aero engine. The twin-spark system used two spark plugs per cylinder, fired by independent ignition coils through redundant DME control modules, improving combustion efficiency and providing the redundancy that made the engine more tolerant of individual ignition component failures. The M64 produced 247 horsepower at 6,100 RPM and 229 pound-feet of torque at 4,800 RPM. The chassis represented Porsche's largest mechanical departure from the previous generation. The 964 replaced the rear torsion bar suspension that had defined the 911 since the original model with coil springs and conventional shock absorbers. This was not a minor change. The torsion bars had been one of the 911's signature engineering decisions. They had given the car its characteristic suspension, geometry, and ride quality, and the change to coil springs represented the most significant departure from 911 tradition in the car's 25-year history. Porsche made the change because the coil spring architecture allowed the suspension geometry to be calibrated more precisely, the ride quality to be improved, and the manufacturing process to be simplified. The traditionalist 911 community received the change with mixed reactions. The engineering case was decisive. The 964 was also the first 911 to receive ABS brakes and power-assisted steering as standard equipment. Both technologies had been industry standard on luxury cars for years. The 911 had survived without them, in deference to the analog driving experience that defined the 911 character. The 964 added both, a recognition that the modern luxury sports car buyer expected the conveniences that lesser cars had been providing for a decade. The body was redesigned to integrate the bumpers into the fender lines, replacing the protruding bumper guards that had defined the G-Series 911. The drag coefficient was improved. The rear spoiler was changed to an automatically deploying unit that extended at higher speeds and retracted at lower speeds, a contemporary engineering touch that the previous 911 had not offered. The interior was modernized with updated controls and improved climate management. The dimensions were preserved. The 964 sat on the same wheelbase as the G-Series 911, with the same interior packaging. These were all credible engineering decisions. The 964 was, on its launch, the most modern 911 Porsche had ever built. The mechanical case for the car was strong. The driving experience, as documented by every comparison test of the period, remained authentic to the 911 tradition. The car earned the respect of the established 911 community, even as it modernized the model line for a new generation of buyers. What the comparison tests also documented, what the magazine reviews acknowledged in passing while focusing on the car's strengths, is that the 964 was not the engineering equal of the NSX. The car and driver comparison test of late 1990 placed the 964 Carrera 4th in a 5-car field, behind the NSX and the Corvette ZR1. The Lotus Esprit Turbo finished below the Porsche. The Ferrari 348Ts finished at the bottom. The Porsche was a credible competitor. The Porsche was also, by the magazine's measured criteria, not the best supercar of the test. The car, carrying 60 years of 911 heritage, had been beaten by a Japanese manufacturer that had never built a supercar before. The 964 at age 35 has an ownership reality that the buyer of a high-mileage example needs to understand before signing the paperwork. The car is, by the standards of the air-cooled 911 tradition, durable in the ways that 911S have always been durable. It is also, by the standards of 1990 supercars, more demanding to own than the NSX it competed against, and the ownership cost differential is real. The single most consequential weakness of the 964 platform is the dual-mass flywheel. The early production 964S, model years 1990 through 1991, were fitted with a dual-mass flywheel manufactured by Freudenberg, a German automotive supplier whose unit proved to be highly unreliable in extended service. The flywheel's job is to dampen torsional vibration between the engine crankshaft and the transmission input shaft. The Freudenberg unit's internal damping system failed predictably at 100,000 miles, or earlier, producing a heavy vibration at low engine speeds and a characteristic clacking sound at idle that owners initially mistook for connecting rod bearing damage. The repair required complete removal of the engine to access the flywheel, a labor-intensive procedure that ran between $2,500 and $4,000 at an independent Porsche specialist, depending on the additional service performed at the same time. Porsche acknowledged the Freudenberg unit's failure rate in mid-1991 and switched production to a higher-quality flywheel manufactured by LUK. The LUK units have proven more durable and have lasted in continuous service for the lifetime of most 964S built after the change. The community of 964 owners that exists today has, in most cases, already addressed the Freudenberg flywheel issue through replacement with the LUK part, or with an aftermarket single-mass conversion that eliminates the failure mode entirely. The cost of the original repair, however, fell on the original owner who had not been informed of the design weakness at the time of purchase. The second consideration is oil leaks. The 964's air-cooled engine architecture, like all air-cooled Porsche engines, develops oil seepage at the case parting lines and at the cylinder base gaskets as the engine ages. The seepage is normal and does not affect engine operation. A 964 with no visible oil drip on the driveway is not a 964 that has been maintained well. It is a 964 whose oil leak is being addressed differently than the others. The Porsche community has accepted the seepage as a characteristic of the engine architecture rather than a defect. The cost of a complete top-end rebuild, addressing all of the cylinder base gaskets and the case half sealing, runs between $8,000 and $15,000 at an air-cooled Porsche specialist. The work is not optional in extreme cases. The work is also not required in most cases. The buyer who can tolerate the visible seepage gets a perfectly functional 964 that needs no immediate intervention. The distributor vent issue affected early 964S with the air-cooled engine. The distributor cap could develop a buildup of ozone-generated corrosion that produced misfires under load. Porsche addressed the issue with a distributor vent kit that allowed the corrosion to dissipate before damage occurred. The fix is inexpensive and is, by this point in the production cycle, almost universally installed on running 964S. The transmission is the Getrag G 55-speed manual on the Carrera 2 and Carrera 4. The transmission is durable. The synchros wear at expected rates and require periodic refresh by mileage rather than failure. The clutch, when the dual-mass flywheel was the Freudenberg unit, addressed as a package replacement, is a normal wear item with normal replacement intervals. The body construction on the 964 was conventional steel, the same architecture every 911 had used since the original. The corrosion protection was the standard German manufacturing approach of the late 1980s. The 964 in a salt belt climate will eventually develop rust at the same points as any other steel-bodied German car of the era. Wheel arches, lower body panels, the underside of doors. The 964 in a Sunbelt climate will preserve its body indefinitely. The cumulative ownership cost of a 964 across 20 years of service, with proactive maintenance and informed mechanical care, exceeds the equivalent ownership cost of an NSX by a meaningful margin. The dual-mass flywheel issue is the single largest contributor to the differential. The engine top-end work is the second contributor. The general maintenance pricing at Porsche specialists runs higher than the equivalent service pricing at Acura specialists. None of these costs is catastrophic, and the buyer who is committed to the car can absorb them. But the cost differential is real, and it is the dimension on which the NSX's engineering decisions have produced their most durable ownership benefit. Production of the 964 ended in December of 1993. With approximately 63,000 examples built across the 5-year production run. The 993 that replaced it for the 1994 model year, the last air-cooled 911, was a more refined and more reliable car than the 964 had been, and it is the 993 that the modern 911 collector community considers the high watermark of the air-cooled era. The 964 occupies an awkward position in the 911 hierarchy. It is the transition between the analog G series and the more polished 993. It carries some of the engineering weaknesses of the early production, run alongside the engineering ambitions that made it a credible successor to its predecessor. The 964's cultural status in the 911 community has grown substantially in the past decade, as the supply of clean air-cooled 911S has shrunk, and the appreciation values have risen across the entire air-cooled range. The 964 Carrera, 2 in clean condition today, sells for between $60,000 and $110,000, depending on year, color, transmission, and ownership history. The 964 Turbo variants, with the carryover 3.3-liter engine from the previous 930 Turbo, producing 320 horsepower, command substantially higher values, with clean turbo 3.6 examples approaching $300,000 at auction. The 964 Carrera RS, the lightweight European market specification, has reached collector values into the high 6 figures. That is the Porsche answer. The 911 that was 85% new but looked unchanged. The car that introduced ABS, power steering, all-wheel drive, and coil spring suspension to the 911 nameplate while preserving the air-cooled engine and the rear engine layout that define the model. And the car whose ownership reality has been defined by the dual-mass flywheel issue and the cost differential against the Japanese competitor that the comparison test had identified as the better choice. The question is, which one was actually the better supercar of the bubble era? And the honest answer requires being clear about what the buyer was choosing between in the showroom in 1990. Both cars were genuinely accomplished by the visible measures the buyer would experience on a test drive. The 964 was the more traditionally engaging car, with the rear engine layout, the air-cooled flat 6, and the unmistakable 911 driving experience that no other manufacturer could replicate. The NSX was the more refined car, with the mid-engine balance, the all-aluminum body, and the daily drivability that no previous supercar had achieved. Both were credible halo vehicles for their respective manufacturers. Neither was a bad car on the day the keys were handed over to the buyer, but the question of which was actually the better supercar has a real answer, and the answer comes from comparing what each car was best at against what each car was worst at. The NSX was best at the engineering achievement. The all-aluminum body was unprecedented in production at the volume Honda achieved. The titanium connecting rods, the VTEC variable valve timing, the 8,000 RPM red line, the chassis tuned by a Formula One world champion. These were engineering decisions that no contemporary supercar had matched. The cumulative effect was a car that achieved supercar performance with sedan-like reliability, refinement, and operating cost. The NSX redefined what a supercar was supposed to be. The 964 did not. The NSX was worst at the heritage. The car carried no motorsport pedigree the buyer could associate with. The Acura badge had been on the market for only 4 years. The lack of heritage was real. It was not, however, an engineering deficiency. The 964 was best at the heritage. The 911 had been the benchmark sports car since 1963. Porsche had won Le Mans more times than any other manufacturer. The buyer who chose the 911 was buying into 60 years of engineering tradition, a motorsport pedigree no other production manufacturer could match, and a community of owners and specialists extending across every market in the world. The 964 was worst at the engineering execution against its contemporary competition. The dual-mass flywheel failure required expensive intervention from owners who had not been informed of the design weakness. The performance figures placed the car fourth in the car and driver comparison test of 1990. Behind the NSX, it had been positioned to outperform. The Porsche carried 60 years of heritage. It also carried engineering decisions that were no longer competitive with what the Japanese manufacturer had built from scratch. Set the two cars side by side, and the verdict tilts toward the NSX on the dimension the magazines were measuring at the time the cars were launched. The NSX delivered supercar performance with sedan-like daily drivability, sedan-like reliability, sedan-like ownership cost, and engineering decisions no contemporary manufacturer had matched. The 964 delivered supercar performance with 911 heritage and 911 driving character. Both cars were supercars, but the NSX was the better supercar by the criteria the segment was supposed to be measured against in 1990. This is the structural pattern of the comparison. The NSX was the better engineered supercar. The 964 was the more legendary supercar. The 911 community has spent 30 years protecting the legend at the expense of the engineering reality. And the engineering reality is that the Japanese manufacturer that had never built a supercar before built a better one than the German manufacturer that had been building the benchmark since 1963. This does not diminish the 964's place in the 911 lineage. The 911 has remained the benchmark sports car for 60 years through engineering iteration, motorsport success, and community loyalty no other manufacturer has matched. The 964 deserves its place as the bridge generation that brought the 911 into the modern era. The 911's cultural prominence is earned across the entire model lineage, but cultural prominence is not the same as engineering victory. The cultural prominence belongs to the 911. The engineering victory on the comparison tests of 1990 and on the ownership data of the 30 years that followed belongs to the NSX. Two supercars from the same era. Different answers to the same question about what a supercar should be. Either car, properly cared for, will provide another decade of service for the buyer who finds a clean example today. The NSX sells for between $50,000 and $120,000. The 964 Carrera sells for between $60,000 and $110,000. Both have appreciated substantially from their original sticker prices. Both will continue to appreciate as the supply of clean examples shrinks. Honda built the engineering revolution. Porsche built the engineering tradition. The buyer who picked the NSX got a car built by a company that proved supercars could be daily driven, reliable, and engineered without compromise. The buyer who picked the 911 got a car built by a company that had been refining the same fundamental architecture for 60 years, and that had earned every dimension of the heritage it carried. Both bets were defensible. Only one of them produced the better supercar by the criteria the magazines were measuring. Before you go, check the link in the description to grab your used car buying guide and avoid getting scammed or overpaying. Trust me, this will help you a lot. Now, click on this next video to see what happens when the same fight, continuity versus ambition, in the luxury segment, plays out in the American market between two manufacturers that were trying to answer the same question Porsche and Honda were answering at the supercar level. Lincoln Town Car versus Cadillac DeVille. It is right there on your screen.